attributes of exponential functions. So these are problems in which the exponent is the variable. So far, we've had the exponent be like 2, 3, 4, so forth, like that. Now our exponent is going to be our variable. And the base is going to be a number. So kind of reverse of where we've been before. And just so you know, base is here, exponent here. That way, when I'm talking about base and exponent, you know what I am talking about each of the problems. So, in your calculator, I want you to graph f of x equals 2 to the x. And so, if you look here, we have to figure out how far up we are. That's 0.2, 0.4, 0.6, 0.8, 1. So it crosses at 1. Zoom out your calculator and see if you can figure out, will this ever cross the x-axis? You don't think it's going to cross the x-axis? Does anybody think it's going to cross the x-axis? There is an asymptote here. So we have an asymptote at x equals 0. We cross the y-axis, so y-intercept of 1. We're going to leave this graphed, but we're going to do another one. I want you to graph f of x equals 10x. Before you graph it, what do you think is going to be different about this graph? Something you think that might happen? Any guesses? The slope you think is going to be different? You think maybe the y-intercept is going to change? Let's find out. And so, did the y-intercept change?
No.
So we still have the y-intercept at 1. And remember, if I was to write that in point form, where would the 0 go? First or second?
First.
First, and then the 1. But what did change? Steepness. Did it change where the asymptote is?
I'm confused about the asymptote.
The asymptote is the line that's going to get close to but never cross. It's going to be more apparent in this one than it was the other one based upon our window. And so our asymptote is y equals 0. I think I may have written that backwards last. Yes, I did. That's supposed to be y equals 0, not x equals 0. Sorry. Those are our asymptotes. These are what is called a growth function, because as we are going towards the right, the function is growing. Think about things in life that have a growth function to them. Population typically has a growth function to it. Bacterial growth. Those that are going to nursing or studying medicine in some form, you're probably going to see a lot of growth functions. Those are things that are rapidly reproducing. Those are going to experience the growth functions. A lot of times you'll see these problems involving around rabbit populations. These will show up on ACTs, so make sure you pay attention to the rules of these things for those that are wanting to go on to take the ACT. So these are growth. because it's growing as I go to the right.
So are you saying that this is a growth chart?
Growth function.
Do you determine that by like how it's doing on the right side?
How it's, as you're going to the right, what's happening?
It's growing.
It's growing. So as I'm going to the right, I'm growing. That's how it's determined. And I'm going to go over some other ways to tell it from the equation, but let's go over what the next one is. So let's do a decay. You can clear your calculator if you like. These, we're going to do f of x. The first one is going to be f of x equals 1/4 in parentheses to the x power. So go ahead and graph that. So on this decay function, hopefully everybody's got it to where it showed up on their screen. What's different about it? It goes the opposite way. It's dropping instead of growing. So in other words, decaying. Radiation, radioactive levels, that's a decay model. That's the most common. That's not the only one, but that's just the most common to use. So, where does it cross the y-axis? At 1. So that hasn't changed. So y-intercept is still 1 or 0, 1 if it's listed as a point. Is there still an asymptote? Yes. And it's becoming asymptotic to that x-axis, which is y equals 0. So that hasn't changed. What do you think is going to happen if I asked you to graph f of x equals 0.0001 to the x? Do you think that's going to be a growth or decay? Decay. So what is the same?
It's a decay.
It's a decay.
It's almost a 90 degree.
It is almost a 90-degree angle. So the smaller that number gets, the closer to 0 that number gets, the steeper the slope. And so, do we still have that same y-intercept?
See?
So, y-intercept is still 0, 1. And tomorrow we're going to talk about how we can change and move that around. But for right now, we're still keeping that same y-intercept.
Wouldn't you change it by like putting 2x or whatever?
2 to the x? Well, we've already tried 2 to the
No,
x.
like he's saying, put it to the power of like 2x.
Oh,
instead
power of
just a
2x?
single
Yeah,
x.
we got it.
Find out. What do you think it will? And so the asymptote is y equals 0. To see if it'll move it to where it's not going through the y-intercept of.
It doesn't work.
It doesn't work.
We thought we were smart.
Okay, so let's think about it. Guys, focus. So far, I've just been doing something to the x power. If this something is between 0 and 1, we called it a decay. If b is greater than 1, we called it a growth. Should there be an equal sign on either one of these? What is 1 to the x power going to look like? A single horizontal line at 1. So we don't ever have any that's equal. It isn't considered growth or decay. So what we haven't ever had is a number in front of that. This number in front is going to determine some other attributes, and we're going to get into that more tomorrow. Today, just realize there can be a number there, and it doesn't change if it's a growth or decay. Okay? So if I give you the problem, I'm going to write up several here, and I want you all to quietly think about them and see if they're growth or decays. First one, growth or decay? Oops, sorry, I'm on the wrong line. I'm hearing growth and decay. So, look at it in your calculator. Which one does it fit? It, you see it growing, so it's a growth. Why do you think it's a growth and not a decay? Because there's a decimal in it.
1.5
Yeah,
is
but
bigger
then it's
than
more
1.
than one.
But it's bigger than 1.
So we're looking at the number inside the parentheses.
So this number is the only number you need to worry about.
Oh, for real?
Well, the other number is going to come into play. Don't get me wrong. But for determining growth or decay, that's the number you worry about. So, this next problem, growth or decay? Because this number is greater than 1. Next one, growth or decay?
Decay.
Because this number is between 0 and 1. And this last one, decay as well, because that number is between 0 and 1. Don't be fooled in thinking that anytime there's a fraction or anytime there's a decimal being raised to a power, it's a decay. That's something a lot of people fall into the problem of.